Hello everyone, this is our video solutions for Can You Do number 7. I'm thinking that maybe these video solutions might be a little bit shorter than other ones because I am making these video solutions from the mindset or perspective that I am in the room with you right now. So if you're watching a solution and something's not making sense, you can just pause this video, raise your hand, and I can come over and walk you through it. So one, if you're watching these at home, that should only be because you didn't watch the lesson beforehand and so you had to use class time to watch your lesson. Otherwise, you're in class with me right now and you are working on this Can You Do number 7. So like I said, if something's not making sense, pause, have me come over and help you. The best way to do this is to do one problem, check your solution, one problem, check your solution, and hopefully a class period is enough for you to make it through one Can You Do. So we'll just get going. First problem is heights of a basketball team. They want you to find the mean. So I got a mean of 75. And then they want you to use that mean to calculate standard deviation, and that is exactly what we did here. So you want to use the framework or the box or the method here to go through and calculate your standard deviation by hand. So I ended up getting a standard deviation of 6.4 inches. And then it says interpret the standard deviation. The heights of the 5 starters typically vary by about 6.4 inches from the mean of 75 inches. That's a pretty big standard deviation. I would say that that is a large standard deviation. We could check this in our calculators. I would highly encourage you to do that. So I'm hoping that I see some of you guys right now pause the video and get your calculator out just to verify that you can do this, because we can check to see if our answer is right. So I would go to my stat 1. I'm just going to put mine in list 6, put in the 5 heights. Then I can go to stat, calc, 1 variable stats, and check my answers. So my mean was right, and my standard deviation is not quite the same. Should I be concerned about that? Yes, because I think I did one of these wrong. Pause. I'm going to check my work and see if I did these wrong. I did do it wrong. On a height of 76, I put 9, -3, and then 9. So your variance should be 156, and your standard deviation should be 6.24. And I believe that now matches our 1 variable stats, and it does. So I did not set that up. That was a true and honest mistake. You guys probably believe me because you see me make mistakes all the time. So it is a good thing that I used my table here to, or my data values here to check my answer. So I need to change this as well, or I guess I could just write a 2 in front of it. Okay, 2. The first 4 students arrived, so we use our calculator on that one. I got a standard deviation of 1.15, and to interpret it, you needed the mean, which ended up being 8. The amount of sleep reported by the 4 students typically varies by about 1.15 hours from the mean of 8 hours. I would write by the 4 students, or at least the amount of sleep reported. I wouldn't just say the amount of sleep typically varies. I would include reported or reported by the 4 students. You want to try to be as specific as possible. 3, which measure of center and spread would you use to summarize the distribution? The mean and standard deviation, or the median and IQR? Justify your answer. The distribution of electoral votes is skewed right with an outlier, so I would use median and IQR since they are resistant to skew and outliers. If you don't have something very similar to that, make sure that you write it in. And this goes back to your SOX cheat sheet. When you're talking about measures of center and spread, that is all based off of the shape of your data. So you look at the shape of your data, and then you go from there. 4. The figure displays computer output on the amount spent by 50 grocery shoppers. What would you guess is the shape of the distribution based on only the computer output? Explain. Once again, shape and summary statistics are related. So shape and mean and median all go together. So when they ask me about shape but only give me summary statistics, or in this case they call it descriptive statistics, you want to compare your mean and your median. Your mean is greater than your median, so the shape of the distribution spent is skewed right, or the shape of the distribution of amount spent. B, interpret the value of the standard deviation. The amount spent by the grocery shoppers typically varies by about $21.70 from the mean of $34.70. And one thing that I have not talked enough about is that you always have to make sure that you include units of measurement on your standard deviation. So now I'm going to go back through and make sure. I've got inches and inches. I've got hours, hours. On this problem, I have dollars, dollars. Standard deviation always has units. C, are there any outliers? That's just 1.5 times IQR. So there is at least one outlier in the data set, and this matches a test question that you had. We don't know for sure if there's more because all we have are the descriptive or summary statistics. So we know that there's at least one, but we don't know how many more because all we know is the maximum value. Please make sure that that makes sense to you. So this would be a good problem where if you have no idea why I mean there's at least one, not just one, you should raise your hand and have me come over. 5 is just a multiple choice. This one was relatively easy for me because I just had to find the one that was squared. It says, what's the sum of the squared deviations? Well, this is in our table. That's what we've been squaring. If I go back to the table that I did on number 1, that's what you're looking for. The observation, subtract the mean, squared. So D as in dog is the only one that makes sense there, in my opinion. 6 is such a good question. 6, probably going to be a test question if I'm being honest. So, which of the following statements must be true about the data sets A and B in the histogram below? So, the mean of data set A is equal to the mean of data set B. Well, in this case, it certainly seems like that would be true because for both histograms, your mean and median will equal because both are symmetric, as I've noted here, and both of them are in the 30 to 40 bin. But that is the issue. That is a bin. We don't know if they're both 35, if one is 31 and the other one's 38. All we know is that they're in the same bin. So even though they're located in the same bin, we don't know that they are actually equal because there are potentially 9 numbers in that bin and even more if this bin or these bins include decimals. 2, The median of data set A is equal to the median of data set B. Same thing as A, because the mean and median are equal. We only know the range of values that the mean and median are in. We do not know the exact values. C, the range of the data set of A is equal to the range of B. Nope. We only know that they are in the same, this should say bin. We know that these are in the same bin, but we don't know exact values. This reminds me I need to go get whiteout. Let me write myself a post-it note, Famil. So we know that these are in the same bin. D, the standard deviation of data set A is less, or E, the standard deviation of the data set is more. So remember, the data set, or the standard deviation of the data set, is how far spread out from the mean data values are. Well, in this one, most of the data values are around the mean, because this is the biggest bin. So that's what I have written here. Most of the data is near the mean. But in this one, most of the data is far from the mean or in the extremes, the lowest bin and the highest bin. So that means that this standard deviation is going to be smaller than this standard deviation because most of data is close to the mean, most of data is away from the mean. So your answer is E as in echo. Please write down all of these supporting notes if you need that to help you understand this problem. 7, you will get one of these as a test question. So 6 and 7. If 7 is not a multiple choice question, it will be just like you had on your exam, and it will be a free response question where you have to describe. So the scores on a test had a mean of 81 and a standard deviation of 9. One student was absent on test day and his score wasn't included in the calculation. If his score was of 84 was added to the distribution of scores, what would happen to the mean and standard deviation? So we want to compare these to the current values. So if we add 84 to a distribution that has a mean of 81, then the mean will increase because the score you added is bigger than the current mean. The score you added is bigger than the current mean. Standard deviation, though, will decrease because the current standard deviation is 9 points away from the mean. But you are adding a data value that is only 3 away from the mean. So the value that you added is only 3 away when the average is 9 away. So standard deviation will decrease because the observation you added is closer to the mean, is closer than the current average from the mean. So if you add 84, it's above the current average, so mean will increase. If you add 84, standard deviation will decrease because the deviation of 84 is only 3. Deviation of what? Well, 84 compared to 81. It's 3 away. So B as in boy. Super important. 5 and 6 are so important that I'm going to highlight them as soon as I find my marker. The important thing behind these is the conceptual understanding, and most of the time that's what shows up on your AP exam. You have to truly understand what standard deviation is to answer this question. You have to truly understand what standard deviation is to answer this question. 8, they give you the mean and standard deviation of marathon times for women and for men. Men have a smaller standard deviation. So if we look at the mean, it took the ladies longer on average to finish the marathon. Standard deviation tells you about spread. So this says to me that the data values varied more for the women than the men. So women have a greater standard deviation, so their finishing times vary more than the finishing times of men, because standard deviation is a measure of spread. You don't have to write that down, but I think maybe I will write it down. Standard deviation is a measure of spread or variance. They prefer variance, but most people use spread. Most people, most AP teachers even. 9, if you watch the lesson, I already went through this with you, 9 and 10. So if you watch the video lesson, which all y'all should have, we don't even really need to go through 9 and 10 because hopefully they're done. 11. George has his average bowling score. Bill has his. Who ranks higher in his or her own league? So you just needed to find, this was like the Home Run Kings problem. So this is exactly like Home Run Kings. So if you're not able to do this one, use Home Run King as your model and then come back. But answer is B as in boy. Bill ranks higher in his own league. Oh man, this bone density problem. Whoo, doggy. So we get the bone density scores for Judy and Mary. So Judy hasn't taken a statistics class. Explain to her what her standardized score tells her about her bone density. So she has a z-score of negative 1.45. So what this means is that Judy's score is below average, so she's below average, but she's further below than most people. So she is below average, but also further below than most people. So I have the average bone density for someone your age is 956 grams per centimeter cubed. And that typically varies by about 11.6 grams. So I think I calculated that up here. Your bone density is below average and farther below most people who are below average. If this sentence bothers you, and farther below most people who are below average, just say instead, your bone density is below average and farther below most people. You can leave out this last statement if it's a struggle for you to understand what that means. All that means is there are people below average. Obviously, 50% of the data is below the average, but she is further below most people on that end. Then it wants to know whose bone density is healthier, Judy's or Mary's, and they give you the z-score, so you just needed to compare them, but make sure you write it in a nice sentence. Mary's bones are healthier because her bone density is above the mean, whereas Judy's bone density is below the mean. So, yeah. So really the hardest one on this guy for me, and this was a challenge for me, how do I describe to Judy what her bone density situation is? You could probably get away with just your bone density is below average and farther below than most people. Okay, family, 20 minutes. I think that this is the shortest solutions video we've ever done. I'm hoping that because this is so short, that means that it's going to be totally doable for you to, my phone just fell, for you to get this Can You Do done within one period. So now what your homework is for you to watch the normal distributions lesson, which is, hopefully you're seeing a theme here, based off of standard deviation. And then when I see you again on Wednesday or Thursday, you will be working on Can You Do 8 in class. Please remember that I will check that your notes are done, and if they are not done, you will be docked points that cannot be made up on your Can You Do scores. Okay? Okay. Love you. Good job.